So as stated earlier, okay, what does it say over there on the schedule? Tomorrow. Reviewing today. What do you got tomorrow? Part 1, Monday. Monday is what? Part 2. Okay? So, with that in mind, let's take a look at what we've learned so far. Okay? If this was an electron dot diagram, if it was, okay, how would we go about doing that, do you think? You're starting with your magnesium, okay, that's right. And what column is magnesium in? So what does that mean to you? But it does have a +2 charge, but why does it? You're right. Because how many electrons does it give away? That's why it's got a +2 charge, okay? So, with that being said, what column is chlorine in? 7. So how many valence electrons is that? Okay, so what we do is we create a chemical bond now. Same thing over here. So if we had to name this, what would we call it?
Magnesium chloride.
Okay. Okay.
Do we have to name one test?
If it would be in a matching or multiple choice question, yes.
There's matching.
Now, what is everything that you can tell me about this compound now? Okay, we can start with that. It's manganese. Manganese what though? And one last thing is you need to be a little more specific. Why is that? Where is manganese located as opposed to magnesium? And since it's in the D block, that's important. Why? It has multiple charges. So how do you know which is this? +2 or +3? Which one are we going to utilize? Why are you right when you say 3? Okay, because remember, the charges have to add up to what? Right. So chloride or chlorine being in the 7th column has a charge of negative what? Okay, so in order for this to add up to 0, okay,
We can't help those who don't help themselves.
okay, what is -1 times 3? Okay, so that must mean this side of this binary compound has -3. So that manganese has to have a charge of what? +3. Now, what are these called? They're charges. What's a more scientific name? Starts with the letter O. Oxidation states. That's what charges are. How they, right. How they, no, these are subscripts.
Yeah, the little numbers on top.
Oh. Yes, oxidation states. Okay, so what do we need to do here yet? Roman numeral 3. Now, with that, do we need to do a Roman numeral for magnesium? It only has one type of charge, and that is +2. Okay, so those add up to 0 now. Okay, Gesundheit. So if you had to do this dot diagram, what would you do?
You'd have magnesium and 3 triangles on the outside. You can do then Cl on.
And then you would just go right around the horn. Okay? So this is a metal and a non-metal. So that is what type of bond then? Why is it ionic? You're right. Because are the electrons shared or are they transferred?
Shared.
Well, Let's look at this. Does magnesium or manganese, will they have any electrons around the metal? No, because it completely gave them away to the chloride ions. Okay? Then notice we didn't say magnesium chlorine. We didn't say manganese chlorine. Once it becomes an ion, how do you know that an element becomes an ion? It gained or lost what? Once it gains or loses electrons, it becomes an ion. Okay? So once this magnesium gave an electron to the chloride ion, it lost an electron. Chlorine gained one, so therefore that's why this is a -1, and that's +2 because the other one went to that side. You got to keep in mind, you young men and women, you've learned a lot so far, okay? The goal is to maintain that, okay? Just like as far as, not turkey, okay?
Chickens.
Okay? The goal is to keep performing at a high level because our expectations for you are pretty high. We're trying to instill a good work ethic in you. Now, you're going to say 8 years down the road, we're not going to be doing this. I can't argue with you. You're probably not. But you are going to be doing different tasks that are required of you, and we're trying to instill that good work ethic in you right now. Make sense? I don't know. Maybe you will, maybe you won't. Well, maybe. Okay? So keep in mind, if elements have more than one charge, it's probably a transition metal and needs a Roman numeral. Now, if you put a Roman numeral 2 there, it's just kind of pointless because, again, magnesium only has one charge. You might look on the periodic table at element number 30 and say, well, zinc, that's in the D block. That must have to have a Roman numeral. But does it? No, it only has a charge of +2. Silver, that's right below it, correct? No, not quite.
Yeah, it is.
Pretty well, it is almost below it to the left. That only has a charge of +1. So you would not need a Roman numeral for it. It's only for elements like chromium, cobalt, manganese. Did I say iron already? Cadmium, tin, mercury, copper. All of those have multiple oxidation states. That's what the Roman numeral's for. All right. So, as we proceed forward, okay, if you had to name this, okay, it's lithium.
Lithium sulfate.
Okay, so what is this specifically called?
Sulfate.
I know, I mean, that's a little too specific. You could say sulfate, phosphate, ammonium, hydroxide. Those are all what type of ions? Why are they polyatomic ions? Because when we look at chloride, okay, how many elements make up the chloride ion? 1. How many elements make up the sulfate ion? More than 1. Make sense? Okay? Do we need a Roman numeral for this?
No.
Why are you right?
+1.
Okay, it only has one type of charge, and that's +1. This one is -2. We've got one sulfate ion. Least common multiple is 2. 2 divided by 2 is 1. 2 divided by 1 is 2. Remember, the answer you get is what tells you to put below. All right. Okay. So what type of compound do you think lithium sulfate is? Is it covalent or is it ionic, do you think? Here's your clue.
Ionic.
Why is it ionic?
Because I was wrong.
because it's got a metal in it. Okay? So if you had to do this electron dot diagram, which element do you think you would start with? Remember, we said you would want to start with carbon if it's there. There's no carbon. You would want to start with nitrogen. That's not there. You might want to start with a metal, but that would be true, but you can't form as many bonds. So therefore you take the element that has the least number of atoms in it. So is it lithium, sulfur, or oxygen?
Sulfur.
It's sulfur because it only has one. Okay? So what column is sulfur in? Okay? I'm going to run out of room here, but how do you want to tackle one oxygen?
Double bonded. Top, bottom.
Okay? You're right. So what can we put here? Maybe it should be a, there we go. And then,
Running low on room.
all right. Is there anything wrong with that?
Yeah, there is.
Yeah.
There is.
Does it have 8? Yeah, there's 8.
One of them is not correct.
The, top and bottom.
Oh, no, that one has a circle on it right there.
It has to be.
That oxygen's got 8. This is what makes that an ionic bond, because that lithium gave its electron to the oxygen. Something wrong with that sulfur.
You have 10.
10 or 12. Okay? When we look at that sulfur, it's got 2 here, 2 there is 4, 4 more. Okay? Okay, so 2, 4, 8, and 4 more. You got 12. Putting them down here. I didn't do that right. I meant to do that. There, I think that looks a little better. Okay, because remember, you want to try to get 8 if it's a non-metal, and if it's a metal, it wants to give it away. And once it has those 8 electrons around it, whether they're shared or transferred, then you know you're done. All right. So therefore, this must be a binary compound. Well, then this is something altogether different because it has more than one type or 2 types of elements in there. More than manganese and chlorine. More than magnesium and chlorine. Here you have 3 different types. Okay.
Are you recording?
I am. Why is that?
I need to watch it.
Oh, okay.
Study for the big camp tomorrow.
But what we're going over now will help you with...
Exam number 2.
Oh. All right.
Bundy lied to us.
So as we go forward, can you see any difference between these 2 compounds as opposed to the ones up above? These 2 compounds as opposed to the ones up above. What are these missing as opposed to everything up above?
A metal.
If it's missing a metal, therefore these cannot be ionic bonds, but rather what instead? Covalent bonds. Okay? So if that's the case, what you would want to do, Notice you can't name these. Well, you could. What do you think this is called?
Chloride.
No.
Or carbonate.
No.
Carbon hydrogen.
Oh, see, that's just it. The only reason you don't know this is because you haven't been taught that yet. Okay? These are organic compounds. Okay? And that's why these are inorganic. That's why you would not know that. So, now, go back to those original rules. Is carbon present? Yes. Yes. Is carbon present? Okay? So, I would suggest you just go through the natural progression. Okay? Carbon is in which column? Carbon is in which column? So this is how you'd probably typically start it. Okay? Now what? You either one. You tell me which one you want to deal with first. Okay?
Wait, put 3 on, but not 4. Put 3 on, but not.
We got to make a bond here yet.
Yeah, we gotta do that. Add oxygen. No, attach.
We're one short.
Attach the next hydrogen.
Do each element, do they have 8 electrons around them?
Yeah.
Each one of them except which one? Hydrogen. But it can't get 8 electrons around it because it's only in column 1. Okay? So, what type of bond is this? Why is it a covalent bond?
It's iodide.
Because it has no metals in it. So therefore, we refer to that as covalently bonded. Okay. Which element would we start with here? Okay. So go through your natural progressions just like we did before. Now what? You want to deal with your oxygen or your hydrogens? Okay. We'll go ahead and put him here.
I have my worksheet back.
Okay. Now what?
Attach hydrogen.
Okay, we can try that. How many hydrogens are left?
2 or 1.
Do we have a problem here? Well, for one, keep your unshared pairs of electrons in the same spot. What's the problem with that? It's only got 6.
I put like. Can I have my worksheet?
Why is that?
Because I think I did something.
Well, dang it. I got them now. Okay?
I forgot my name, I think.
So, how would we go about fixing this? Okay? So, we got to do that in a specific manner. We'll just do it like this. Okay?
Add a hydrogen on.
All right. That would be correct. Okay? Then the last thing, we'll go ahead and show you, what does it mean if it is a halogen or a gas? It's got a specific name to it. These are all what if they're by themselves? Starts with the letter D. Not double bond. You have to put a 2 behind each one of them because they're diatomic molecules. Okay, now, if that is the case, what is the simplest covalent bond? Why is that? It's in the first column. That is the simplest bond you can make. 2 hydrogens.
Is nitrite supposed to be?
It should be nitrate. Yep. Okay. Then last thing I want to do, okay, if we just did H2O. Okay, this oxygen's got its 6. What else would we do? Okay. Now, what happens with this is a special bond because we already had said that water really doesn't like to play by the rules for two reasons. One, when water freezes, what does it tend to do? And that's one of the properties of water. And does water conduct electricity? Yes. And the reason it does that is because these electrons are kind of resonating back and forth between one another. That's called a polar molecule. That's what water means. It's a polar molecule. Okay? That was one of the questions on your vocab quiz. If you got a 9 on your paper and you put hydrate instead of polar molecule, said, yeah, I can see why you would put hydrate on there. But a polar, yeah.
They're kind of the same.
Right. But when you're talking about water, it is a polar molecule. Okay? All right. Is there anything else? No, this is all part 2 on Monday. But just in case we don't have time.
Dot diagrams?
What's that?
We're going back to the dot diagrams on the part 2?
That was part of this chapter, yes.
Oh,
I mean, we don't have to go over these. I thought maybe it would be a benefit for you.
Oh, that's good because I needed a recap. Hey,
Okay?
Did you hand out our vocab then from whenever?
I did.
back like a week ago.
I was just making sure you did that.
Okay? Is there anything else?
No, sir.
Should we watch some wrestling? No, we should watch that. You say home development or no?
Okay, so in case you can't read that, there's a glare. Approximately around 1835, John Deere made a name for himself because of this invention. Okay? And then on square balers, okay, not big round balers, but the square balers that you pick up, typically there's a big flywheel on the outside. There's a specific type of pin on there. Let's say a rock is about ready to go through the hopper, and all of a sudden it jams that flywheel. There's a specific type of pin that will break.
No, he didn't say that.
He didn't say that. He didn't say it. He said share. He said share. I only wrote it down.
We'll catch up to you next time.